Welcome back. This is lesson 4.4 about graphing quadratics. We'll get more in depth with this when we get to lesson 4.5. For today, we're really just going to focus on putting things into vertex form and then a general idea of how vertex form helps us graph quadratics. So let's get cooking with our intro to graphing quadratics. So first thing that we need to understand is what this parent function looks like. So we've talked about parabolas and some general characteristics. We've talked about kind of what they look like, but today we're going to use vertex form to graph quadratic. In order to do that, first we need to understand what the graph just y equals x squared looks like. So y equals x squared has a point at 0, 0. If I plug in 1, I get out 1. I plug in 2, I get out 4. I plug in 3, I get out 9. I'm not very good at counting. I think 9's right here. And then the same thing happens over on the other side. And so what I get is something that looks, I'm going to draw this the best that I can. It's not easy to draw this little writing pad, but something that looks like this. So it's this kind of U shape that opens up, has its vertex on the origin. And we're going to talk more about what a vertex is in just a second. But this is the general shape of the graph of y equals x squared. The reason we need to understand what this graph looks like is because when we put something into vertex form, it transforms this graph, meaning that it moves the graph around in the coordinate plane for us to figure out what the graph looks like. So let's take a look at what vertex form is. So vertex form is a form of a quadratic, and we saw this back in our first or second lesson. But the reason this form is helpful is when I have a quadratic written like this value h can give me the x coordinate of the vertex. This value k can give me the y coordinate. And then this value a can cause a vertical stretch or compression, or if a is negative, it would cause a reflection. So when we talked about parabolas previously, we noted that parabolas either open up or down. If a is positive, then the parabola will open up. If a is negative, then it'll open down. And then we can use h and k to figure out where the vertex is at, and then draw ourselves a rough sketch of the parabola. So let's take a look. Oh, and also, I think we've mentioned this before, but the vertex of the parabola is the coordinate at which the parabola attains its minimum if it opens up, or its maximum if it opens down value. So it's the point at either the very top or the very bottom of the parabola. So let's take a look at one. So right here, if I look at this in vertex form, then I know that h equals 7, because you notice in vertex form, this says x minus h. So right here, I have x minus 7, so h equals 7. K would be equal to 2, which means that my vertex is at this point 7, 2 right here. So now what I want to look at is I'm going to say, all right, this number out here, -2, this is negative, so my parabola is going to open down, and it's going to be a little bit skinnier. Oh, that was terrible, terrible picture. It's going to be a little bit skinnier than that graph of just y equals x squared. I can't really draw with this writing pad, but you get the idea. The general idea here is I can find the vertex, figure out which direction this opens, and then we're going to do some more analysis with this graph in the next unit. But today our focus is just getting a rough sketch of what this parabola looks like. So I'm going to leave this example for us to do in class. You can try and do this for yourself before we get to class. But this example, I'm just going to ask you to find the coordinates of the vertex, which this should say +2. Sorry about that. So we just did the coordinates of the vertex for this one and which direction opens. But what I really want you to focus on is trying to figure out the axis of symmetry for this quadratic. And we'll do this together in class. All right, so the question then becomes, what if the quadratic is not already in vertex form? So what if I have a quadratic that's not already in vertex form? Well, we've done something before that will allow us to put it into vertex form, and that's complete the square. So what I would do is I would complete the square. So I'm going to factor the 2 out of the linear and quadratic terms. So I've got 2 times x squared plus 4x plus something minus 4. So in this case, I need to figure out what needs to go in this blank right here. So I take 4 divided by 2, and that's 2, and then 2 squared is 4. So I'm going to complete the square and say, all right, so this is x squared plus 4x plus 4. But now I need to remember, I need to keep in mind, I don't have an other side of the equation here, but what I do have is just an expression that I can't change the value of. So when I add a 4 in here inside the parentheses, I've really added 8 to this whole expression. So in order to maintain equality, if I add 8, I'm also going to subtract 8 so that I can maintain equality. And now what I'm left with is 2 times x plus 2 squared minus 12. And now this would be my quadratic in vertex form. We'll do practice with that in class. That's really one of our main goals of class on well, Wednesday, today, is to write this in Vertex form. So the rest of this is just some practice writing things in Vertex form that we'll do in class. So if you have any questions, well, I guess I'm uploading this like right before class, but if you have any questions, this will be a good place for you to come and watch after class. And if you need anything else, email me, let me know. If you're not sure about the answers to any of these questions, let me know. We will hopefully get through all of it in class, but I will see you in a couple hours, and I hope you have a fantastic day. I'll see you in the next video.